Have you ever been driving on a freeway when the speed limit suddenly changes? The lanes are the same, the pavement is the same, the curves are the same. Sometimes the only thing you've done is cross a state line. If the road didn't change, then why did the speed limit? Most people assume speed limits are calculated using one scientific formula. In reality, transportation engineers collect the same kinds of data, but different states and cities use that information in different ways. One of the most common methods of determining the speed limit is called the 85th percentile rule. Engineers measure how fast drivers naturally travel when traffic is light and the weather is good. Imagine a graph showing the speed of every vehicle. The point where 85% of drivers are traveling at or below becomes one of the main pieces of information used when choosing a speed limit. The thinking is straightforward. Most drivers naturally choose a speed that feels reasonable for the design of the road. If the posted limit is close to that speed, more people are likely to obey it. Other transportation agencies begin with a different goal. Instead of focusing primarily on how fast people naturally drive, they place greater emphasis on reducing the severity of crashes. Roads with schools, frequent driveways, pedestrians, bicyclists, or a history of serious collisions may receive lower speed limits even if many drivers would choose to travel faster. Road design matters too. Wide lanes, gentle curves, long sight distances, and clear shoulders make drivers feel comfortable driving faster. Narrow lanes, parked cars, trees close to the roadway, and frequent intersections naturally encourage slower speeds. In many cases, changing the design of a road has a greater effect on driving speed than changing the number on a sign. Physics also plays a major role. Every time you drive, there are two parts to stopping. First is your reaction distance, the distance your car travels before you even touch the brakes. Second is the braking distance, the distance needed to bring the vehicle to a stop. As speed increases, both become longer. Crash energy increases even faster. Double your speed and you don't double the crash energy. You roughly quadruple it. That's one reason many agencies choose lower speed limits in areas where pedestrians and cyclists are more likely to be present. Freeways introduce another engineering debate. Some states post one speed limit for passenger cars and a lower one for large trucks. Supporters argue that heavy trucks need longer stopping distances and can cause more severe crashes because of their weight. Critics point out that different speed limits create more passing, more lane changes, and larger speed differences between vehicles. They argue that keeping traffic moving at similar speeds may reduce conflicts and improve traffic flow. All these factors explains why the speed limit can change even when the highway doesn't. Cross from one state into another, and the pavement may stay exactly the same, but the transportation agency responsible for that road has changed. The engineering data may be similar, yet the priorities used to set the speed limit can be different. The next time you see a speed limit sign, consider that it isn't simply measuring the road. It's the result of engineering studies, road design, vehicle physics, traffic behavior, and public policy all coming together to answer one deceptively simple question: how fast should people drive here? If you like learning how everyday things really work, please subscribe to this channel and like this video. Thanks for watching, and I hope to see you soon.